Here's problem 1914. 1 mole of ideal gas has a temperature of 25 degrees Celsius. If the volume is held constant and the pressure is doubled, the final temperature in degrees Celsius will be, well, even though we want a final temperature in Celsius, we're going to have to work with Kelvin if we're going to use the ideal gas law. And in general, then, we would have that our initial pressure and our initial volume over our initial temperature is a constant. That's equal to our final pressure, final volume, over our final temperature. And in this case, our initial temperature is 25 degrees Celsius. Add 273 to that is going to give us 298.15 Kelvin as our initial temperature. The volume is held constant, so our initial volume equals our final volume, so we'll just say that's equal to V. And the pressure is doubled, so our final pressure is equal to twice our initial pressure. So, let's solve this for our final temperature. Final temperature will equal the final pressure over the initial pressure times the final volume over the initial volume times the initial temperature. Just rearranging this ideal gas law here. Alright, our final pressure is twice our initial pressure, so this is going to be 2 times Pi over Pi. Pi is canceling out, times, and then our final volume is the same as our initial volume, so those cancel out, and then our initial temperature is 298.15. So we're going to get 2 times 298.15. $596.3 Kelvin. That is our final temperature in Kelvin. But we know that the temperature in Kelvin is equal to the temperature in Celsius plus 273.15. So our temperature in Celsius is going to equal our temperature in Kelvin minus 273.15. That's going to be 596.3 minus 273.15, and that equals 323.15 degrees Celsius. So that is our final temperature in degrees Celsius when the pressure is doubled but the volume is held constant. 323.2 degrees Celsius.